Hey, welcome to the Precalculus Chapter 11 review. I'm just going to go over a couple of strategies on this page before I go into detail on how to solve a couple of these on the next page. So you just need to look for things, like if you see cosine squared and a sine, those aren't the same, so you're not going to be able to solve it like you can here or factor it like you can in other problems. So you're going to want to replace this with an identity that has sine in it, like 1 minus sine squared. And don't forget to distribute the 2. The same thing with this. Of course, they are both in terms of cosine, but this is cosine and this is cosine 2x, which you're not really sure what to do with. So what you're going to do in that case is you're going to replace it with an identity. So you're going to look at the 2x identities and find one that's only in terms of cosine. For instance, the identity 2 cosine x minus 1, 2 cosine squared x minus 1, that can replace this, and then you can get everything on one side, like add the cosine to both sides, add the 1, set it equal to 0, and solve for the zero product property. All right, for another instance, down here, this is a little tricky. Number 7 is a little tricky. So it's just cosine equals sine. You can't replace it with any identities. Maybe you're not sure what to do. But what you can do is you can divide both sides by cosine. Now, I always caution you guys against dividing out a variable, which is what cosine is, or a function. And you are simplifying it here, but you're leaving it on this side. You're not dividing out a cosine. So you have 1, but you still have cosine here. You have both sine and cosine. So this won't mess up your solving. And sine over cosine is tangent of x, and then you can just solve that. So when we go to the next page, before we do that, on this we have, if you notice, we have the two different functions. As long as it's set equal to 0, you are fine. You can use the zero product property, and you can set each piece equal to 0 and solve. And for something like number 11, don't forget when we have a squared, do not forget plus or minus. Also, it's good to take the square root of things and simplify them. This is 1 over 4. So when I take the square root of both sides, I've got a plus or minus. So I get cosine x equals plus or minus. The square root of 1 is 1, and the square root of 4 is 2. And then you can solve it. So now we're going to do a couple of more difficult ones, like number 3 on the next page. Okay, first we're going to look at number 3. Yes, when you graph it, here's the answer. And you're like, how did you get these answers? We actually don't have both of those answers because we're going to solve between 0 is less than or equal to x is less than 2 pi. So really this 2 pi is not going to be counted, and we're only going to have one answer. But how do we get that? So you're going to let u equals x over 2. And when you do that, that makes it just kind of easy to think of sine of u equals 0. And that happens when u equals 0 and pi. However, we don't have u. We want 2 to the x. So we are going to let u go back to x over 2. And that equals 0 and pi. And then to get rid of that, we're going to multiply both of these sides by 2. So we're going to multiply everything by 2. Multiply pi by 2 and 0 by 2. All right, so x is 0, and that's cool, and x is 2 pi, and that's not going to work because, again, of our range. So this answer is not what we need. We only need x is 0, which makes sense because originally we had 2 answers, but since we had x over 2, we're going to divide those 2 answers. We're going to have half as many answers, so we kind of knocked out one of the answers. All right, for the next problem, we have cosine of 3x equals 1. Same kind of deal. You can let u equals 3 to the x, and then cosine of u equals 1. And where does that happen? Where is cosine 1? So between 0 and 2 pi, cosine is only 1 at one place, and that is 0. So u equals 0, but we don't want u, we want 3x. So we put 3x equals 0, and we divide by 3. Oh, and guess what? X is still 0. But don't forget, in the original graph of cosine, it is here. Here's the original graph of cosine. Between 0 and 2 pi, it only hits 1 time. However, if you notice, 3x means it goes 3 times as fast. It means the period was ending here, but now we have 1, 2, 3 periods of cosine because it's going 3 times as fast. That means it was hitting at 1 time, but now it's hitting at 1, 2, 3 times. Well, how do you find that? That means you have to know the period. So cosine of 3x, what is the period? Period equals 2 pi over b, and b is 3, so our period is 2 pi over 3. So basically, every 2 pi over 3, this cosine repeats. So it's 0 here, and then after 2 pi over 3, it's 0 again. Now, without a graph, how would you do that? All you do is you take your 0, and you add 2 pi over 3, and that gives you 2 pi over 3 is another answer. And then you add 2 pi over 3 again, because it happens every 2 pi over 3, and you get 4 pi over 3, and so you get really excited, and you just add 2 pi over 3 again, and then you get, 6 pi over 3, but 6 pi over 3 is 2 pi, and remember, we're going between 0 is less than or equal to x is less than 2 pi. So you kind of just keep going, really, until you get to 2 or get past 2 pi, and then you're done. All right, have an awesome evening, guys.